Isaac Newton was born on December the 25th, 1642, in Woolsthorpe, Lincolnshire, England. His father, also named Isaac, had died 3 months before his birth. His mother, Hannah Ayscough, remarried when Newton was 3, leaving him in the care of his maternal grandmother. This early separation shaped a childhood marked by solitude and self-reliance. From a young age, Newton displayed an intense curiosity about the natural world. He spent long hours observing simple machines, building small mechanical devices, and experimenting with light and motion in ways that intrigued him more than formal lessons. Unlike many children of his time, he learned by doing, rather than merely listening or memorizing. Newton attended the King's School in Grantham, where he received a classical education that included Latin, Greek, and arithmetic. While competent in these subjects, he often found himself more engaged by the practical and experimental aspects of study than the traditional curriculum. Friends and teachers noted his quiet demeanor, sharp mind, and determination to understand how things worked. At 14, he returned home for a period due to his stepfather's insistence on farming as a profession. Newton struggled with manual labor, finding it tedious and unfulfilling. Instead, he turned increasingly to reading, studying mathematics, and performing experiments. This period reinforced his preference for solitary study and shaped his habit of focusing deeply on problems for extended periods. In 1661, Newton entered Trinity College, Cambridge. There, he studied the standard curriculum, which emphasized classical texts and Aristotelian philosophy. While he mastered the required material, Newton devoted his free time to more modern thinkers, such as Galileo, Kepler, and Descartes. He began developing his own ideas about mathematics, motion, and the natural world, laying the groundwork for discoveries that would later revolutionize science. By the end of his early years, Newton had established habits that would define both his personality and his scientific approach. In 1665, a severe outbreak of the bubonic plague swept through England, forcing Cambridge University to close temporarily. Isaac Newton, then a student at Trinity College, returned to his family home. While this could have been a setback, for Newton it became a period of intense focus and productivity. During this time of isolation, Newton began to study the fundamentals of motion, gravity, and optics more rigorously. While at Woolsthorpe during the plague years, Isaac Newton spent much of his time observing the world around him. One of the most enduring stories from this period involves a falling apple. The apple, simple and ordinary, sparked a profound question in Newton's mind. Why do objects always fall straight to the ground? This question was not the result of a sudden epiphany, but of careful observation and reasoning. Newton considered the forces acting on the apple, the motion of the moon, and the paths of planets in the sky. He began to realize that the same force that caused the apple to fall might also govern the motion of celestial bodies. This line of thought laid the foundation for his law of universal gravitation. He did not simply speculate, he calculated, tested, and refined his ideas. He compared terrestrial motion with astronomical phenomena, gradually forming a unified understanding of the forces at work in the universe. By studying motion in both practical and abstract ways, Newton began to see patterns that had eluded others. He developed concepts of acceleration, force, and the laws of motion. Building on his observations during the plague years, Isaac Newton began formulating principles that would describe motion in precise mathematical terms. He studied how objects moved on Earth and in the heavens, seeking rules that could explain both the fall of an apple and the orbit of the moon. Newton's approach combined experimentation, observation, and mathematics. He defined concepts such as force, mass, and acceleration, recognizing that objects respond predictably to forces acting upon them. These insights became the foundation for what we now call Newton's 3 laws of motion, which describe how objects move and interact. Isaac Newton's work on motion and the natural world required precise mathematical descriptions. To solve problems involving changing quantities, he developed methods that would later be recognized as calculus. Calculus allowed Newton to analyze motion in a way that algebra alone could not. He could calculate the slope of curves, determine rates of change, and describe the acceleration of objects under force. This provided a mathematical framework for his laws of motion and universal gravitation. Newton's development of these tools was driven by necessity. He encountered problems that existing mathematics could not solve, and through innovation, he created new methods. His work on calculus was initially communicated in personal manuscripts and correspondence, as he refined the techniques and applied them to physical problems. These mathematical foundations not only enabled Newton's immediate discoveries, but also provided tools that would underpin centuries of scientific progress, from engineering to astronomy. Isaac Newton's extraordinary achievements did not occur in isolation. Throughout his career, he engaged with several scientific rivals, most notably Robert Hooke and Gottfried Wilhelm Leibniz. These rivalries were rooted in both intellectual competition and disputes over credit for discoveries. Hooke challenged Newton's work on optics and gravity, prompting debates that tested the rigor of his ideas. While some exchanges were tense, they also pushed Newton to refine his arguments and provide stronger evidence. The disputes demonstrated the importance of critical review and verification in the scientific process. A more famous rivalry emerged with Leibniz over the invention of calculus. Both Newton and Leibniz developed similar methods independently, leading to accusations and heated controversy.
In his later years, Isaac Newton continued to contribute to science while reflecting on the work he had accomplished. He remained involved in the Royal Society and maintained oversight of the Mint, ensuring standards and integrity in both institutions. Newton's personal life continued to be private and reserved. He had few close relationships, dedicating the majority of his time to study, correspondence, and administrative duties. Even in retirement, he remained engaged with scientific questions, reviewing and refining his earlier work. During this period, Newton received recognition for his contributions. He was knighted in 1705, a testament to his influence and the value placed on his discoveries. Yet despite fame, he remained methodical, disciplined, and focused on understanding the natural world rather than seeking personal acclaim.
Thanks for watching. I'm Charis Peter. See you in the next video.